So looking at the first question, right? You have five identical spheres, right? One, two, three, four, five, between two blocks in order to measure their diameter, right? So from here to here, how many millimeters are covered? Oops,
Millimeters.
millimeters, yeah, or centimeters, yeah. Sorry.
Oh, I was so confused. Uh,
Yep.
10.
Are they 10? You're moving from 15. Here's 15 from 5, and this is 16. So how many?
Oh, okay. 11?
Yes, so it's 11 centimeters in total. And we have how many balls or spheres?
5.
5. So 11 over 5. What is 11 over 5 as a decimal value?
11 over 5. Oh my god, I hate fractions. Oh, it's.
So it's 11 over 5, right? So just do long division. 5. 2 gives you 10. 1. And another 2 gives you another 10, 2.2. And that's your value. You have 2.2. Yeah.
Okay.
Okay. A student wants to take a particularly accurate measurement of the volume of liquid in a measuring cylinder. Which of the following procedures would make her measurement less accurate? So you're losing accuracy. Which one of these would make you lose accuracy?
Mhm.
Can you judge just from the options given?
B?
D. Using a set square to make the cylinder perfectly vertical. Why would that
No, I said B. I
reduce
said
accuracy?
B.
B. Bottom of the meniscus. Why would that make it
Parallax
less
error?
accurate? 1 second. Parallax error. You're supposed to be using the bottom of the meniscus. Depends on what kind of meniscus you have. Wait a second. So the answer is C. Okay. B is right because you're supposed to be using the bottom of the meniscus. When you measure and you have a beaker like so, or a test tube or a measuring cylinder, you're supposed to measure from the bottom of the meniscus. That is the value of volume that you get. Okay.
Could you
So
explain how C is wrong?
yeah, C. C using the largest measuring cylinder. So when you have a large measuring cylinder and you're using a small volume, it is more difficult to measure a smaller volume using a larger cylinder.
Oh, okay.
So it's easier to measure. It's more accurate when you use a smaller, measuring cylinder. When you're using something larger like a beaker, you have the margin of error increases because there is a larger volume to be occupied, right?
Oh, I see. I see.
So ideally, you're supposed to be using the smallest measuring cylinder that you can find, which is able to take the volume that you are giving it, right? A student is timing the rate of cooling of a beaker of water on repeat run of the investigation. The student forgets to zero stop zero the stopwatch. Zero the stopwatch means you subtract everything and you turn it off and reset it. Okay. The readings on the stopwatch at the start time and the end time are shown in figure 1.1. So this is your start time. And as you can see, it's not starting from zero, right?
Yes.
Okay. So how long did the beaker take to cool if you have to subtract these values?
1 second. Uh, 12. Wait. Oh my god. I'm getting a little confused because I'm writing it down and I just keep mixing up the numbers.
You can do it on your own time. It's fine. We're in no rush.
I might be wrong because I have a lot of error when it comes to understanding numbers in particular. But is it 11? Wait, not 11. 12 and 19. 12 and 8.
Well,
Sorry, 12
yeah,
and 8. 12 and 8.
it is D. Okay. So you would go 23 minutes, 27 seconds minus 11 minutes and 19 seconds. This comes out to 8 and this comes out to 12. So 12 minutes, 8 seconds. Extended. Okay, so this is not worth doing
Wait,
since we're.
before we continue, I just wanted to mention one thing, which you'll probably notice a lot, is the reason I didn't take commerce in school was because I didn't have enough marks in math. So, and
Okay.
that happened because something I have a problem with understanding numbers in particular. For example, if you even tell me like 5 multiplied by 7, that would make me confused because I start forgetting if seven's bigger than 5 and stuff like that.
It's fine. You can write it down and take your time. But since you've taken science, right, you're not going anywhere without physics. So,
I see.
yep, you'll have to work on it a bit. A person wishes to roast a chicken. Roast chicken. The chicken requires 1 hour and 20 minutes in the oven to be properly cooked. The oven must be switched on 10 minutes before any food is put in order to preheat and reach the correct temperature for cooking. The chicken needs to be ready at 4:30 p.m. What time must the oven be switched on? So you've got 10
3 p.m.
minutes here. Yeah. So an hour and 30 minutes. Before that is 3 p.m. A particularly diligent student wants to measure the volume of some liquid for an experiment. She has two measuring cylinders available, a large 250 ml one and a small 50 ml one. The liquid will fit into either of the two measuring cylinders as expected. The liquid forms a meniscus where it touches the side of either measuring cylinder. Which cylinder would should the student use to get the most accurate result from, and from where should she measure the liquid level? Okay, so again, what type of measuring cylinder did we say is more accurate?
The smaller one because if it can
Small
fit
one.
into both, if it can fit into 50 milliliters one, so it should be that one.
Yep, the
It's
smaller one,
D.
right? And bottom of meniscus, exactly. A geologist. A geologist wants to measure the volume of a particularly interesting pebble. Okay, so she found in the river. She uses the apparatus below. What is the volume of the pebble? Do you understand what's going on here within this question?
I do, I think, because when you put the pebble in, wait, I don't know how to phrase it, but I do understand.
So what's happening is you're basically displacing this water by entering this pebble inside, right? So what happens is you have the volume of this added to the already volume of liquid which was
11?
inside. So this is how much? What's the first? How much is the volume for the first beaker or measuring
Sorry.
cylinder? It's 6, right?
Oh, six, 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 six. Sorry.
Okay, so this is 6, and how much is this? So 15, 16, 17, right?
The screen is glitching. Go on.
Yeah.
So 11.
Yes. So the value is 11. A scientist is trying to determine the volume of three identical pieces of a new material. She places them in a measuring cylinder as shown in the diagram. The first cylinder shows the level of water in the measuring cylinder before the pieces are added. So here. And the second shows after the new material is added, right? And they say that there are three of these. Okay. So when they're asking each piece, so they're asking for one of these, right? What is the volume for one
Yeah.
of these? Yeah. So you have how much volume increasing after the addition of the new material?
Well, is the first one on 50 because it's a little blurry. So the first one is on 50,
Yes. 50.
and the second is on 90. So
So the
that
difference
is a
is
40 increase. So we will do 40 divided by 3.
exactly so 40 over 3, which is how much?
40 divided by 3 is wait, 13.3.
Yes. Three blocks are placed
So hard
into.
questions.
Yeah, there's a lot of calculation going on. And there's just more of this when we go forward. So this is just the beginning. Three blocks are placed into three measuring cylinders. These are shown below. Okay. So let's say what is the difference in the first one?
It's wait, 30.
30. And in the second one,
Wait, I need to do something. So the first number is 23, and the other one is 84. 61.
61. Yeah, 61. 20 cube. And here, how much is the difference?
43 and 70.
Yep,
So it'll be 27.
27. Okay. So you've got 27, you've got 61, you've got 30. So which one has the largest volume and which one has the smallest volume?
The smallest volume is the third one, and the middle one is the largest.
So ZXY, option D.
It's D.
Yep. Okay. A student is trying to see how quickly they can run 5 kilometers on a standard 400-meter running track. The reason they reason if that they know how fast they can run one lap, they can assume they will run at the same speed for 5 kilometers and calculate their predicted time. They correctly reason that they will not be able to maintain their initial pace throughout the whole 5 kilometers, so they decide to time lap 5. The diagram shows the readings on the stopwatch at the beginning and the end of lap 5. Calculate how long it should take the student to run 5 kilometers.
I don't understand this question.
Okay, so it says hard questions for a reason, right?
Hmm.
So 5,000 kilometers, 5,000 meters, and you have 400 meters is the track, right? And he's supposed to be moving 5 kilometers, right? Each lap is 400 meters. So the total amount of laps that he'll run is how many? 12.5, right? So he'll run 12 and a half laps if he wants to complete 5 kilometers. So he's running one lap in how much time? Can you tell me the difference of this again?
The difference between them is 203.
11, 10, 13, 9, right?
Oh, three,
So,
three, three.
so what is the time difference, right? The time difference is 7, and once you take one from here, it's 6, 57, and now you have 10 here. So 10, and this makes 1 minute 57 seconds per lap. So each lap takes 1 minute and 57 seconds. If they multiply this by 12.5, so how much would that be? I'd rather just make this into seconds, which would be how many? 117 seconds. Yeah. So 117 seconds multiplied by 12.5 gives me 1462.5 seconds. And if I divide this by 60, I get 24.375. So the option that I'll choose is the one with 24 minutes. So what we did, to make a long story short, is we took out the number of total laps that he will run, right? And we multiplied that by this time period. Okay, make sense?
How do we take out the total number of laps that he's gonna run for 5 kilometers?
How did I get this?
Yeah,
So each lap that he's running right now is like 4 kilometers, right? 400 meters, right?
yeah,
So he decided if I run one lap, I can text how much it will take me through that lap, how much time it would take me to learn the total 5 kilometers, right? He was basically trying to find a ratio, right?
okay.
Okay. So that's what he did. And if he runs 400 meters 12.5 times, the total distance he's ran is 5 kilometers, yes or no? Yeah.
Yes.
So that's what he did. And he found the time it takes for him to run one lap, and he multiplies this by 12.5, and now he knows how long it will take to run the entire 5 kilometers. Okay, makes sense.
Okay.
So basically, if you've done ratio proportion in math, so he did time laps. One lap, 117 seconds. 12.5 laps, x, and then you cross multiply. An Olympic cyclist rides around a velodrome track 5 times. A velodrome track, I don't know if you've seen, but they're like circular and you ride inside them. Okay.
Okay.
It shows the reading on the stopwatch, which was used to time the laps. Unfortunately, the person using the stopwatch started it a little early, so the stopwatch reads 2 seconds when the cyclist starts. Okay. After one circuit, it's 14.04 seconds. So this is actually how much? 12.04 seconds. Yes. Yeah. And at the end of 5 circuits, it's actually 79.21 seconds. Yes.
Yes.
What is the average time to complete one lap of the velodrome? So you have 79.21 and you have 12.04 as well, right? So can you divide this by 5?
Do I work by 5?
This time,
79.21.
yeah. Yep.
Fifteen something. Wait. 1584.
Yeah. So C. Okay.
Yes.
Now, a student uses a ruler to determine the circumference of a wooden dowel. She puts a mark on the dowel, then rolls it along a ruler 3 times before reading the position on the ruler at which it stopped. So it moved once, twice, and thrice. What is the difference of the dowel? What is the circumference of the dowel? So it started from 1 centimeter and ended at 13. Then it ended at 25. Right? And uske baad, after that, it ends at 37. Yeah.
37.
So what is the difference? The first difference is 12. The second difference is 12. And the third difference is 12. So the circumference of the dowel is
12.
12. Yeah. Okay. Let's look at some theory questions. Hmm. Some students observed drops of water falling from a tap that leaks as shown in figure point 1.1. Okay. The student measures the time for 50 drops to fall from the tap. The time for 50 drops to fall from the tap is 20 seconds. What is the average time between two drops falling? So if you have
2.5.
50 divided by 20 gives you the time for one tap, one drop, right? Which is
2.5.
2.5. But they're asking, yeah, between two drops. So you have 2.5 seconds.
Wait, can I read the question again for a moment?
Yep. Sorry. We've messed up. You're supposed to do 20 over 50 because it's going to be the average time, right? And you have 50 drops. So it's going to be the time over the number of drops. Okay, so that's 0.4.
Is the answer 0.8?
0.4.
Oh,
It's 2 over 5, right? Okay. So
this
in the
was a
marking
little
scheme, you'll get
confusing.
1 mark for this, and you will be allotted 1 mark for this fraction and this answer. The student collects some drop of water. The students measure the volume of the water they collect. They state the term for the equipment that is suitable for measuring the volume accurately. What is the apparatus used? Called a measuring cylinder. Make sense?
Yes.
Okay. In a similar experiment, another student collects 1.21 kilograms of water. Calculate the weight of this water. Okay. So when we're talking about weight, weight is 10 newtons. Basically, weight is mass multiplied by g. G is the gravitational constant. So weight is equal to 0.21 into, you can either take 9.81 or you could take 10, but it's probably better that you take 9.81 or 9.8, which would give you how much?
Repeat what you said.
Okay. So weight is a force. Okay. It's not a unit, normal unit name, right? So it's not a normal unit. It is when you have, is the action of gravity on an object. Okay. Make sense? Yeah.
Yeah.
So weight, in another sense, is the product of mass and gravity, or the gravitational field strength, or the gravitational constant, right? So the gravitational constant on Earth is 9.81. This is something that you have to remember because it helps in every question almost, right? Wherever gravity is mentioned. So you have the gravitational constant, which is 9.81, and you have the mass, and their product is how much?
Is 2.0601.
Okay, so it's 2.06, but I would prefer that you to round it off to 2.1. Okay,
Okay.
so that you have two significant figures or one decimal place. Okay, this is going to be the last question that we do today. I have another engagement after this. So let's do this and then we'll end class.
Okay.
Four students PQR and S each attempt to measure the time period, the timetable, uh, time for one complete oscillation of a pendulum. So an oscillation is this movement, right? One movement to and fro directly from here to here.
The back and
Okay.
forth movement in a regular rhythm of a
Yes,
pendulum.
that is an oscillation. Yes. So from here to here, that is an oscillation. The arrows show the movements of the state the student who has chosen the correct movement for one period of a pendulum.
S, because I
Yes,
heard somewhere that that's
exactly.
right.
Exactly. But however, if this student, this one, would have taken this as his time period, he would have been correct. If this student would, okay, this student cannot be right at all. And if this student extended here, right, yahan tak, so this student would also be right if he did this, and if he did this, he would also be right. So it should end where it started. Where you're looking here, it's ending at the center and it started at the center. If it started from the right and ended at the right, it would be right. If it started from the left and ended at the left, would have been right. Okay.
Okay.
Okay. Another student uses a stopwatch to measure the time taken for 50 periods. 50 periods of a pendulum. Figure 2.2 shows the time taken on the stopwatch. So it's this long. A minute and 23 seconds. A minute and 23 seconds and, well, 0.37. So it's 1 minute, 23.37 seconds. So if we are supposed to take out the time for one period, we will divide this time by 50. And the first thing that I'll do is make this all seconds. So it's 83.37 seconds. Can you give me the time for one period or one oscillation?
What was it in seconds?
83.35.
I'm not sure.
83.37 divided by 50. What is the value?
1.66.
1.67 when you round it
Oh,
off.
okay.
Okay. So 1.67 seconds. So here what you do is the first thing that you'll find is 1 minute 23.37 seconds. You will convert this to 83.37, which will give you 1 mark, right? This will give you the second mark, and sorry, this will give you the second mark, making this fraction, this conversion, and this will give you the third mark, which is the answer, 1.67. Okay.
Okay.
The student measures the displacement of the pendulum from its rest position. The displacement is 16.5 as shown in figure 2.3. State the displacement in millimeters. So you have centimeters. Can you tell me the answer in millimeters?
16.5 centimeters into millimeters is 165.
165 millimeters. Okay. So I guess we can keep it here for today.
Okay.
Any questions?
No, but I think like at the starting it was easy, but then it just kept on getting harder, and I think it's hard. Like
It,
at the end, not now.
it's a little confusing when you have numbers, right? So once you
I'm not
do
good
some
with
practice,
numbers.
once you do some practice, you'll be much better. So it's fine.
Okay.
Okay. Any questions?
Nope.
Okay. Classes.
Okay.